Let's multiply by twos. In this video, we are going to learn how to multiply when we have 2 as a factor. Do you know what the time sign means? The time sign actually means equal groups of. That means if we have the multiplication expression 2 times 3, that is the same as 2 equal groups of 3, or 3 plus 3. You might be thinking, why do I see an adding symbol when we're talking about multiplication? Multiplication means repeated addition. 2 times 3 is the same as 3 plus 3 because 3 plus 3 is just 2 groups of 3 or 2 threes. You might notice this is a doubles addition fact. If you know 3 plus 3, then you know 2 times 3. You can even think of these 10 frames to help you. 3 plus 3 is 6. That means 2 times 3 is also 6. Let's try this strategy with another twos problem. 2 times 7 is the same as 2 equal groups of 7, or 7 plus 7. Think about your doubles adding facts. Do you know what 7 plus 7 equals? Does this double 10 frame help you? 7 plus 7 is equal to 14. That means 2 times 7 is also equal to 14. If you know your adding doubles facts, you actually know your multiply twos facts. Is 2 times 7 the same as 7 times 2? Let's take a look. Well, we just said that 2 times 7 is the same as 7 plus 7. So what would 7 times 2 look like? That would be 7 equal groups of 2, or 2 plus 2 plus 2 plus 2 plus 2 plus 2 plus 2. Phew, that was a lot of counting. The bottom problem looks like skip counting. You can count by twos 7 times. In the top problem, you are adding 7 twice. Both of them equal 14. So 2 times 7 and 7 times 2 both have the answer of 14, just using different ways of adding. When the factors can be flipped in a multiplication problem and get the same product, that is called the commutative property of multiplication. So if you see a problem like 7 times 2 and you want to add 7 twice, just flip it to 2 times 7. You'll still get the same answer either way. Take a look at this hundreds chart. All of the multiples of 2 are highlighted. What do you notice and what do you wonder? You can pause the video and come back when you're ready to think and discuss. Here are some things that I noticed. First, when I skip count by twos, I land on all even numbers. All multiples of 2 are even. All of those numbers highlighted are even. That also means if you are multiplying a whole number by 2, your answer will be even. Skip counting by twos gives you all of the answers to a twos multiplication problem. 2, 4, 6, all of those are multiples of 2. So that means if I'm multiplying a number by 2, my answer will be even. I also noticed that when I'm looking at the skip counting chart, it could take a very long time to skip count by twos to get to some of these greater numbers. So adding doubles can be a more efficient strategy than skip counting by twos. Now, let's think, how can we use this noticing to help us? If I'm solving 2 times 9, say I'm skip counting by twos or I'm adding 9 plus 9, and I get 17, my brain should have alarm bells that that answer is incorrect. That's because 17 is odd, and all whole number multiplication problems that multiply by 2 are even. 2 times 9 is actually 18, which is even. Can we use this same twos strategy with greater numbers? What if I wanted to solve 2 times 35? That would be the same as 2 equal groups of 35. I could draw an area model, use the algorithm, or use another strategy to solve 2 times 35. I could also just think of adding doubles. This is the same as 35 plus 35. I could add that in my head by doing 30 plus 30 and 5 plus 5 and adding them together. Or maybe you have another strategy for mental math. I could also stack and add using the algorithm. 5 ones plus 5 ones is 10 ones. That would be 0 ones and regroup 1 10. And then 1 10 plus 3 tens plus 3 more tens is 7 tens. Either way, 35 plus 35 is 70, so 2 times 35 is also 70. This strategy works for any number that is multiplied by 2. Now you know how to multiply by 2's.